This is PreAP Pre-Calculus, free response practice number 26. No calculator. Point A has coordinates 3, 4, and B has coordinates 4, 3. Answer the following questions. If C has coordinates negative 4, 3, then is triangle ABC scalene, isosceles, or equilateral? Show your work, give a reason for your answer based on that work. Well, we're going to have to find the length of AB, the length of BC, and the length of AC. And in each cases, we're going to use the distance formula. The distance formula is the square root of the sum of the change in x squared plus the change in y squared. The x values for A and B, just going to make sure this is clear to me. These are A, B, and C. The x values are 3 and 4. Difference, delta, means subtract. The y values are 4 and negative 3. 3 minus 4 is negative 1. Haven't squared it yet, so got to keep it in a grouping symbol. 4 minus a negative 3 is like 4 plus 3, which is 7. Make sure that your square root bar comes all the way over top of this. Negative 1 squared is 1. 7 squared is 49. This is the square root of 50. 50 is the product of 25 and 2. 25 is a perfect square. Its square root is 5. 2 is not a perfect square, so that's 5 square roots of 2. BC. So I'm looking at this right here. I'm going to take B minus C. You can take C minus B. It doesn't matter. So I'm going to have 4 minus a negative 4 squared plus negative 3 minus 3 squared. Subtracting is not easy. 4 minus a negative 4 is like 4 plus 4, which is 8. Negative 3 minus 3 is like negative 3 plus a negative 3. That's a negative 6. 8 squared is 64. Negative 6 squared is 36. If you sum those, you get square root of 100. Square root of 100 is 10. The length of AC, which I'm looking at these ordered pairs now. I'm going to take top minus the bottom. 3 minus a negative 4, it's going to be 7. And 4 minus 3, it's going to be 1. So I got 7 squared plus 1 squared. 7 squared is 49. 1 squared is 1. This is square root of 50. This is 5 square roots of 2. So the question is it scalene? Scalene means all sides are different length. Isosceles, that means at least 2 sides are the same length. Equilateral means all sides are the same length. So we would say, therefore, triangle ABC is isosceles because at least, pardon my capitalization in the middle of a sentence, that is lowbrow. 2 sides are congruent. That finishes A. I'll just make sure that we finished A. Determine which of these is true, which we did right here. Show your work, which we did right here. Give a reason, which we did right here. So as far as points go for this would be worth 2 points. You would get 1 point if you did all these correctly. And you would get 1 point for this answer here. That includes saying it's isosceles and essentially the definition of isosceles triangle. All these 2 sides are congruent. B. Based on your results from part A, determine if triangle ABC is a right triangle or not. A couple different things you could do here. To determine if it's a right triangle, let's start this out by establishing. If triangle ABC is a right triangle, then the square of each leg, well, let's not say that. Let's not say that because we don't know if they're legs or not at this point. The square of each smaller side added together equals the square of the longer side. So we're setting ourselves up now to see if this is true. Now to see if this is true, we can take our two smaller sides. Now if you're thinking, I don't know what's bigger, 5 square roots of 2 or 10, well, look at the previous step. Square root of 50, square root of 100, square root of 100. Obviously square root of 50 is going to be smaller than square root of 100. And in fact, to make this math easier, I'm just going to use the non-simplified version. Square root of 50 squared plus square root of 50 squared. We want to know, does this equal square root of 100 squared? Square root of 50 squared is 50. Square root of 50 squared is 50. Square root of 100 squared is 100. Does 100 equal 100? Sure does. So then our conclusion, therefore, triangle ABC is a right triangle. This is worth 3 points. We get 1 point for essentially naming the Pythagorean theorem. And in fact, I should actually use the Pythagorean theorem by name. Let's see here. Put a comma here, according to the Pythagorean theorem. You know what, and I can clean that up a little bit to make this easier. I'm going to do that. Make this easier to write. It's a mouthful there. Let's do this. By the Pythagorean theorem, x squared plus y squared equals r squared, where x and y are legs of a right triangle, and r is the hypotenuse. Hypotenuse. If I say that, which I just did, and then I write this equation, and it ends up being true, then we know that this is a right triangle. I mean, actually, to be more specific, this is the converse to the Pythagorean theorem. But I don't think we need to get into that. So anyhow, you get 1 point for that. You get a point for this work. And you get a point for then concluding it's a right triangle. Part C. The point 3K is a point that is equidistant from both A and B. Find possible values of K. All right, so I'm going to call this point D. So this is saying that AD must be the same length as point BD. I'm going to use the distance formula. Change in x squared plus the change in y squared should equal the change in x squared plus the change in y squared. For A and D, I'm just going to rewrite the coordinates for A down here. Let's see, A was 3, 4. I don't want to mess this up, so I'm going to write this down. I suggest that you would write it down there as well, but that's up to you. B has coordinates 4, negative 3. So for A and D, that's these two. Difference of my x values is 3. Difference of my y values is k minus 4. And then I'm doing from D to B. Difference of my x values is 3 minus 4. Difference of my y values is k minus a negative 3. So this simplifies a bit to 0 squared plus the difference of k and 4 quantity squared equals the square root of negative 1 quantity squared plus the sum of k and 3 quantity squared. Now at any point we could square both sides to get rid of this radical on both sides. So let's do that. 0 squared is 0, so we're just going to get k minus 4 squared. Over here we're going to get 1 and k plus 3 quantity squared. If I square these things, we're going to get k squared minus 8k plus 16. That is either using the box method, using the distributive property, or using the acronym FOIL. And then over here we're going to get k squared plus 6k plus 9er. I can subtract k squared from both sides. And then if we decide to subtract 6x from both sides, we're going to get negative 14k, subtract 6k from both sides, plus 16 is 10. If we subtract 16 from both sides, we get negative 14k equals negative 6. Dividing both sides by negative 14, we get negative 6 over negative 14, and that reduces to 3/7. So for this problem, we would get a point for that, and we would get a point for that right there. Be 2 points for this part of the problem. All right, thank you very much.